Hey guys, hope you're all doing well. Today I'm actually going to be starting on another adventure and just going to bring you guys along the whole adventure of this one. I think you'll enjoy this. So what we've got here, don't look much right now, but it's a empty Moog cabinet. This is actually a vintage Moog modular cabinet. Some of you may remember the Moog Modular I redid about 2 years ago, the Moog 1C I redid for Andy. Well, this was actually part of that system. The original owner who purchased that Moog Modular, I want to say his last name was Robbins, he actually purchased this cabinet with the idea of putting modules in it, you know, as time progressed. Unfortunately, you can see how far that idea got. So it's been sitting for 50 years as an empty cabinet. And so what we're going to do is we're going to fix it up for Andy. He kind of told me what he wanted to do and kind of make him an expansion system to go with his Moog. And so that's what we're going to do here. But I'm going to first just start by showing you the cabinet, and I've already started cleaning it up so you can kind of see it looks shiny because I've got some conditioner on this veneer. So I'm just kind of letting it kind of soak it in and kind of help. It does have some scars, you know, it's old, it's vintage. But cleaned it up really good inside. This was about as dirty as the Moog Modular was when we started with it. Same storage, so it's pretty much in the same place. But it already has all the rails and everything in it, the aluminum rails that you use for, you know, mounting the panels. Something that's interesting is actually I already had to do some work to this one. This particular bar right here, this aluminum bar, was never actually threaded. So I had to take this off and tap the holes for 632 thread is what these use. And for those that are curious about how Moog did this, I'll show you. So what they did is they use wood screws to hold in this piece of aluminum, and then they use machine screws, 632 thread, to actually hold in the panels. So that's how Moog did it. And so this one here didn't have any of these holes actually threaded, so I had to go in there and actually tap the holes. So took care of that. I've already done just a little prep work. I had to do a little modification to the cabinet in like some of the wood areas. You can see I've actually had to kind of get this cleaned out. Of course, you can see some residue there where I hadn't cleaned it fully yet. I had to kind of notch that for the idea of what we're going with here. But anyways, just going to give you a look down the cabinet here before we start. So this is, like I say, the vintage Moog cabinet, which is really cool, and it goes great with his you know, system that he already has because it's the same era. So it's pretty cool. So 1972 is when this cabinet was actually sold. But anyways, let me go back here. I'm going to put the other idea on the table of what we're going to be using as part of this system. Alright, so here's the system that we're going to be using to fill the Moog cabinet up. There's going to be some updates, of course, from this unit to the expansion. But what we have here is a really nice synthesizer.com portable 22 system. And so this is going to be basically the starting point for his build. But for those that aren't familiar with synthesizers.com, they're really great 5U modules, so you get the full size like you do on a Moog. But I like them really for 3 reasons. 1, they're made in the USA, so we're supporting a US business. 2, they're using a lot of legacy components in their designs, so there's nothing like really super rare you got to go try to chase down to fix something. And then 3 is that they have a great turnaround time when you order something and great support. So you can pretty much pull any data sheet you want to for any of these modules if you have any problems. And you can get a pinout, you can get all the information you need as far as calibration, etc. And then also just the fact that, you know, if you need a module and they don't have it in stock, they got a really fast turnaround. So just a great company to work with. I've been working with them now for probably about many years. I started back in 2012. When I actually built my system, which I've got here. There's my portable 22 system with one of their keyboards, and just a great system. I really do like it. But one reason I got mine here is because before I ordered some of the stuff, or before I put it in his module, I want to test some ideas. So there's some things I've tested, I really like them, so we're going to be implementing it into Andy's system. And so just a great thing. For those that are wanting to get into 5U modular systems, check out synthesizer.com. You know, you're not going to pay $5,000 for one oscillator, for example. You know, you're going to find this stuff to be very affordable. because I do use a lot of legacy components. They're easy to maintain, they're easy to service, and that's why I really like them. You know, there's nothing like really super rare you got to go try to chase down, or you know, or have to go overseas to try to, you know, order something to fix something, or you know, that kind of stuff. So that's why I like Dotcom. They're just really great systems. But this one here was a perfect purchase because we've got it used, saved a lot of money, and it actually gives us room on Andy's budget to do some really fun stuff as far as some updates and things like that. So it's a great system. But I'll show you what we've got in this one, and I'll kind of walk through what we're going to be changing. So the Midi interface, the Q104 is actually going away, and it's going to be updated to the Q174, which is a much better Midi to CV conversion system. The issue this one has in particular is that when you play two notes, like let's say that you're holding down this key and you hit this key, if you let off this key it drops this note. Same thing below, so if you hit the lower key and you're holding this key, it drops that key. So it's a real nuisance, especially if you're doing a lot of fast playing. It doesn't let you do some types of playing either because of that dropping notes. So we're going to be updating the Midi, and part of that though is I'm going to be actually building some circuitry to make the Moog Modular work with Midi as well. So it'll actually share this between the Moog Modular and the Dotcom. So it'll be a really nice you know, kind of expansion for him as well. He'll still have his keyboard for his Moog Modular, but if he wants to go Midi, he can do that. He has that option. So we got the Midi, we got the instrument interface. This allows you to actually control things from external sounds, like for example guitar, microphones, drum mics, etc. So it's really handy for triggering envelopes and stuff, and actually processing the audio through your system. So really nice module there. I think that's the Q118. The Q105 is the slew limiter. Basically this gives you glide and portamento. It's really nice because it's directional, so you can actually select what you'd want it to do up and down. We got our multiples here. We got multiples, for those that don't know, they're just a set of jacks tied together. So you put in a signal to one, like an input, and then the rest are outputs of that signal. So you can use it for patching multiple things off one signal path. And it's just passive. There's nothing active about it. It's a Q124. We got 3 Q106 oscillators here, and I've actually already pulled them out, and they've got the updates, so they're fantastic. So 3 oscillators, which are fantastic oscillators. We got a noise source, Q110. We got a Q117 sample and hold module. This is a great fun little module right here, because you can get sample and hold by using noise into it, or you can patch an oscillator into it and get some really cool stepping through the waveforms if you use a low frequency oscillator, like an oscillator into LFO mode. You can do some really fun stuff with this. We got a 4-channel mixer, Q112, which will be what you put your audio into to summit. We got a ring modulator, which is going to be a lot of fun. That's the Q116. We got 2 Q109 envelope generators, which are ADSR based envelopes. We got a signal processor, Q125, which is actually how you can set your controls for positive and negative gains and offsets and inverts. Really handy, especially with some of the CV stuff, when you're wanting to convert one signal that's this way into another signal that's that way for 2 different functions, 2 different locations. We got the state variable filter, the Q107. This is actually a pretty nice little filter. It doesn't have the resonance and stuff like you think of a transistor ladder, but it's not bad. I would put it more in a category of sounding like an ARP filter, but it gives you more options than just low pass. So it's got a high pass, band pass, notch, and low pass. So you got 3 different outputs you can use, and they're all voltage controlled. So voltage controlled high pass, voltage controlled band pass, voltage controlled notch filtering, and of course low pass is voltage controlled as well. So it's a really handy module there. Then we've got the Q108 amplifiers. So these are VCAs. You can use them for audio or for, you know, mixing CV signals and that kind of stuff. They're actually pretty cool because they're sort of like a dual system. So you can actually use the input 1 with an attenuator, which works great for volume control. But you can also put stuff into control input 2, and you have a separate signal here. So you can mix the 2 signals internally, or just have one that's control only. You don't have an attenuator. So as soon as that VCA is, you know, turned on, you'll hear that signal. But really nice amplifiers or VCAs. You can set them in linear or exponential, which is really nice for different applications. We got a pan fade module, which allows you to pan signals based off CV or manually controlling them, or you can switch it to fade and then fade a signal in and out. So you can get like a tremolo effect. So pretty cool stuff there. But that's what we got. So that's pretty much what this system is. So like I say, the updates we're going to be doing is I'm going to be changing things around quite a bit, getting a little bit better order. I'm going to be adding a normalization module, which actually kind of does what Moog does, where it kind of pre-wires some of the signal paths. So for example, all the gates will be connected, so anything that has a gate will be tied to a jack down here. So Midi, when you plug in the Midi and gate, you have to patch all your gates, so it saves on patch cables. But at the same time, they're making break jacks, so if you plug something into the gate, you can actually break that signal and use external gate signals. So that's really nice. Same thing with the pitch. We'll have a pitch input as well that'll do the same thing. I'll be walking you through all this as I do this too. I'll be showing you how these kits work and showing you how to wire these things in for those that are curious, that are not familiar with this stuff. But anyways, that's just a first look. I'm going to start tearing this thing down, get all these modules out, and then we're going to start actually, doing some fun stuff here. Alright, I've started moving some modules over to this Moog cabinet here and get an idea of the flow rate. I haven't done any kind of wiring or any of that kind of stuff yet. Just typically just getting the modules in position and playing with the ideas of where I want them to be. So as you can also see, we've got some of the modules I ordered in that's going to be part of this update. So once again, got rid of the Q104, went with the Q174 and 175A MIDI interface aid, which is going to be really nice. This is going to be a really great update. So what this does is it gives you some of the same things you find on the Q104, such as the gate, trigger, pitch, velocity, but you get more stuff and it's got a better functionality. So for example, as I mentioned earlier, how the Q104 drops notes, this doesn't have that issue. It doesn't drop notes. So that's, first off, really huge. The second thing is, it's really nice about it that I really like, is that it has an add-in. So you can add extra CV into it and it'll sum it up with the pitch. So you can actually use it as a summing circuit as well for this input. We've also got some other great things, such as pressure control on this jack here. Now these are multiple, these are 3 jacks. They can be used in multiple applications by flipping the mode switch. But number one is probably one of my favorites. It's actually got aftertouch or pressure control. So if you got a MIDI controller with aftertouch, this will actually give you a CV voltage off that aftertouch. So you can patch it in and get like pitch bends and some really fun stuff there. That'll be really, really fun stuff. So that's great. In mode 1, that's aftertouch. This jack here is off velocity. And then 1 is trigger. So it basically gives you a trigger like you find on this one here. When you go to mode 2, this jack becomes pitch 2, which is also really cool. That's a secondary CV voltage. So it actually will, if you have 2 keyboards set up, which Andy has more than 2 keyboards, he can actually use MIDI from another one and it actually generate a secondary CV voltage when you're in mode 2. And then 3 is actually a second gate. So you can actually use a secondary CV and gate output to basically make 2 entities of a different synthesizer. So you can have basically 2 CVs and 2 gates for 2 different synthesizer controls, which is really nice. It also gives you velocity 2 when you're in that mode. When you flip to 3, what this does, it gives you CC control. So CC1, CC7, and CC4. So if you have a MIDI controller with like knobs, you can assign them to these controls, and when you turn that knob, it'll give you a CV voltage out for that control. So some really nice features there. And then what you've also got is you got a trigger mode. So you got multiple trigger, release trigger, so it'll trigger when you hit the note, and when you release the note, it'll also trigger again. Then you got single trigger, so single or multi-trigger. You've got prioritization of your notes. So it can be last note priority, low note priority, or high note priority. So really nice features there. So like I said, it really opens up more than what you get with this kit here, with some updated control over your MIDI. So really great stuff. The Aid is an expansion off this. So what it does, it gives you multiples. So we got multiples output of pitch, multiples output of gate, and they're actually tied to the jacks here, the gate and the pitch. You get an arpeggiator, so you got control over arpeggiation, which is kind of cool. You can do 1 octave, 2 octave up. You can do up mode, up, down, or down by flipping the switch here. And you got a gate time, which is really nice. And then it also gives you portamento. So you got a portamento control of linear or exponential. So exponential would be more like your typical Moog modular glide, that kind of lazy glide sound as I refer to it as. Or you got linear, which is more like your Minimoog glide. So it gives you some more options there as far as your portamento goes. This next module is one I brought up earlier. It's the normalization. That's another update we did. We added this one. And like I was mentioning earlier, this hardwires some things, so you don't have all the patch cables to go to all the CV stuff, which is really nice considering the fact that you can see that all the MIDI and gates and CV stuff is down this end, and your oscillators are all the way on that end. So this is going to keep you from the patch all the way from over here down there. Alright, I'm going to show you real quick how the actual normalization panel works here. So I'm going to just take one of these out and show you how the modification works, and it's pretty simple. So this is one end of our let me see if I can get here on my camera. This is one of the make and break jacks that comes on the end of the normalization module. And so this is what the jack looks like. You can see that you got your 2 wires coming in, and then you got a plug already wired in. So what you do is you take one of your modules. For example, we're going to work on gate, so make sure you have your pitch and gate separate so you don't mix them up. But we're going to replace this gate jack with this make and break, so it's actually got a normalization gate input. So I've already loosened this with a socket, so it takes a 1/2 inch socket, and so just loosen this, and then what you'll do is take the old one out. As you can see, take the nut and washer off. There's our jack loose now. You can see that that's no longer mounted, and you can kind of follow out your wiring. So we can actually see here that our wiring, let me actually turn it this way, try and do this while I'm looking at my camera screen. So you can see our wiring here. It goes up to this jack right here. We can unplug this one, and then now we can actually remove the original jack. So there's our jack that we've removed. Set it to the side. We no longer need it. Now we'll take our new jack right here. If I can get this right on camera. It's hard doing this looking at a camera screen. So we'll take the nut and everything off here and the washer, and then we'll actually put it in place of where our gate jack was. For example, you can see how that's going to look. We'll put our washer and our nut back on there. And you don't want to over torque these things, so you just want to put it on there, and you want to get it. I usually do hand tight with a socket. I hold the socket in my hand. I usually like to use a deep well socket because you can get a better grip. And I just kind of hand tighten them. And then what I'll do is once I get them hand tightened, I'll give them just a little nudge with a wrench. Just slight. I mean, not much at all. Just a little snug. That way they don't come back loose. And so do that, and then you'll run your wiring back where you have that other one plugged in. Just give me a hand around there. Get here in a minute. Let me. Still looking at a camera screen trying to do this. There we go. All right. So then you just plug that in place where the old jack was, and there you go. And there's your normalization gate socket installed. So you'll do that basically for all of them. Some of these are going to be a little bit more tricky because some of these you actually want to remove the circuit board in order to get behind it so you can get the jack out. So I wouldn't recommend unplugging all this. Just take it loose, pull the board up, because you usually got enough harness on these things that you can pull it up. If you have one or two that are a little tighter, you can unplug those. Just make sure you know where they go in the orientation. You can see how most of actually all of them, the wires go to the outside. So when you plug these in, the wires will be coming to the outside, not the inside. So that's one way you can remember not to reverse these. Plus they got a clip, so these connectors will let you put them in one way. You can see the little tab there on the connector. Maybe you can see that. It's got a tab on one side, and that's actually what latches to the teeth. So I can show that. I don't know if my camera will show that or not. You can see that little edge on that, and it actually will click in and it locks in. Alright, so here's an example of a make and break jack. Now this is a TRS. You can see that it has the ring section of this. So you have tip, ring, and then sleeve would be like your ground connection. So a TS is what we're dealing with these particular applications. But you can kind of see what I'm talking about as far as a make and break. So if you look right here, you'll see a little reed that comes out right here, and it's actually making contact with a tip. So what would happen is, well, you've got a pin for the reed right here where you'd solder in, and so this would be a signal input to that reed. And then when you plug something into the jack, when you plug a 1/4 inch in, what would happen is it would actually push down on this tip bar, breaking. You can kind of see I can break a little bit with my hand right there. It would break that reed connection, and then that's actually how you'd now inject the new signal rather than having that signal that's hardwired in. So that's how that's actually how a make and break jack works. So when you hear the term make and break, that's what I'm referring to, is how this jack responds. Not all these, you have to order a make and break jack. They don't come all like this. You actually have to order them. But that's what you're looking at right there. This would be an example of a TRS make and break on the tip. So that's how that works. Alright, so still working on this modular here and making some great progress on it. So I'm doing a lot of modifications to it, as mentioned. That's what I'm kind of doing at this state. I've got everything working. I've installed the larger power supply in it, which I'll take you on back. I'm still working on the wiring, so excuse the mess here. But got the bigger power supply in there and routing all of our harness, cleaning things up really nice, and just kind of keeping it as clean as I can. Got our power module installed back here. That's where you actually plug it in. And so calibrated the power supply and got all that working right. And if we go around here, I'll show you some of the modifications I've done here. So just as mentioned, I've tied the envelope generator to the VCA using a make and break jack here. You can kind of see the new jacks compared to the old ones. So did that here, so now I don't have to patch from the output of this envelope into the VCA to use this as an audio VCA. You can see I don't have anything plugged in. If I hit a key, you can see it works. And you still have your output, so you can still use it in conjunction just like you could originally. As you can see, I've done actually on this one. I've got this one here used going up to the filter, using it as a filter sweep, but same thing to the VCA here. We've got this VCA tied into this envelope generator. So VCA envelope 1, VCA envelope 2. So you can kind of think of this layout. I also modified the transistor ladder filter and the state variable filter. I've added a toggle switch here that actually turns key tracking on and off. And I added the 1 volt per octave here, so it's all tied back to the normalization, so you don't have to necessarily patch everything to get your filter tracking, etc. But you still have the option to use external 1 volt per octave channeling if you want to. So you can kind of hear how this works. The filter, hear it tracking the keyboard, turn that off, fixed frequency. So you can see how that works. Same thing for the state variable. I've got the same kind of switch here and replaced the 1 volt per octave here with the make and break as well. So that's how all that works. Other modifications I've done is I've actually modified the sample and hold module. Once I put the jack in this one, I put the gate from the normalizations panel in this one as well. But what I found is that even when you're internal, it would trigger the envelopes, and I didn't have really a way to control that. So what I did is I modified the circuitry a little bit and fixed it where it actually works now correctly with the external signal. So when you flip to external, it works, and then when you turn internal, you can hear it's not triggering the envelopes. Something else I did though is I modified the circuit so it's a non-latch trigger. So you can actually make it auto trigger by flipping the switch. As you can see, it's not doing anything until I hit a key. So if I hit a key, actually close the envelope up here, open that filter up. as you can see. As long as I hold it in a key, it'll trigger. We can turn that off, and you can see it doesn't do anything. And then if we go to external, you can see I can hit a key and it will actually change the sample. Now I've got a oscillator sync set up on oscillator 3 here, and you can hear it actually. But we can flip the switch on. Okay, I gotta go back into internal here. That works. Put that switch back off, and it's only going to fall out the envelope generator. But it's also very punchy. You can get some really good like punchy sounds. We'll actually turn all the oscillators on here and make this thing have a little bit. So we can go. So that's just an example of that modification I did to this, and I'll show you guys how to do that. I'll make a separate video on how to modify your sample and hold module for those that want to do this modification. It's not very hard, and it's really just adding one component and cutting a trace, and then adding a switch, a toggle switch, and building a little wiring harness. So you'll need to know how to solder, but it kind of opens this thing up quite a bit for that purpose. But the main reason I did that is because I'm using normalization for this. So I got the gate tied in, so I don't have to patch into it to make it have a keying gate sample. So that's what that does. But besides that, everything else is pretty much stock so far. Still got to build the Moog Interface stuff that's going to happen. That's going to go in the back, so it won't actually be out here. It's going to be a calibration procedure as far setting this up for the Moog Modular, and then vice versa. So this will actually work the Moog Modular, or the Moog Modular will work this. So that's the next things I'm going to be doing. I just got the panels in today to do that, so that'll be happening. But anyways, just going to give you an update. Alright guys, it's a few weeks later here, and as you can see, this thing has progressed quite a bit. It's grown a little larger than we had really anticipated. But it's all good. It's all really good stuff here, and I think Andy's going to be really happy with it. But really nothing's changed much below except for this module right here. So as I had mentioned that I was going to work on an interface module for Moog to make this thing interface with Moog, vice versa. So this is the module I came up with. I ended up putting it on the front because of the way it works, the way I kind of designed it. It just ended up being more practical to be on the front. And so what I've done here is I've actually got basically two entities of this module. So we've got one section that's actually from the Moog. So this would be the CV and S trig from the Moog coming into this thing. And it actually does a conversion to gate, and it also has the circuitry needed to make this thing actually range and scale. So you don't have to detune an instrument to try to match the frequencies. And so you can keep everything nice and clean and in tune, and then you just tune it up with your trim pots in this thing. So I got multi-turn trims. This is actually a circuit I built quite a while back. I think I actually built the circuit for Evan, is where I started this. Evan Kelly, your Minimoog. This is kind of where this circuit idea came from. But I've actually just continued to modify it on this round, and I've kind of revised it quite a bit, made it work better than what I had originally made. So I'm really happy with how it's working. So we got that. So we got the Sense Jones jack input, coupled to Sense Jones to make it authentic to the Moog Modular, and so that's how that works. So yeah, you got the S trig in, gate out, CV in from the Moog, and then CV out, which will go to your normalization module, or it can go to the add in over here on the Midi interface, and you can actually transpose using Midi as well. You can transpose the Dotcom using Midi while you still have CV control from the 950 Moog keyboard. So that's really nice, and it's you can turn it on and off with a switch, so you can actually have the ability to still turn it off and just have this standalone, or actually mute the system, so to speak, when you're playing. So we got that side, and then we've also got the other side, which does exactly the opposite. So this is actually two Moog. So it has gate input, and it has the CV input and CV out, but gate in to S-trig out, so it's got the conversion circuitry needed inside. And on this side I've actually done a hard wire, so we've got the normalization panel tied into this. So we've got the CV input is actually a make and break jack, and the gate in is a make and break jack, so you don't actually physically have to patch these into anything to get your CV from your Dotcom system. So you don't have to do anything. All you got to do is plug CV out and then the S-trig out to your Moog. Flip a switch, it activates, turn it off, it goes away. So that's what I came up with there. So really nice module. I think it's going to be a really nice module for Andy here, and it might be something I produce if you guys show interest in this. You guys out there that have modulars. I could also make it a standalone unit. You know, this could actually go in a box on its own right and be its own device. So just kind of keep that in mind. Let me know in the comments if you guys would be interested in something like that, because I've got some other things coming up too. So there's that. Now the big thing is we got an extra cabinet, and so I hope I didn't put Andy in a spot with this thing, because this wasn't my intention. But what I'd originally wanted to do is Andy actually reimbursed me for the full amount of that modular Dotcom we bought that was used, and it had that black cabinet. So what I was going to do is I was going to take that black cabinet, make an expansion cabinet, and just put the power stuff in it for him, and just make it, you know, make it a nice extra kind of cabinet for him, just to kind of surprise him with it, really, is what I was going to do. And that way he didn't have any waste. You know, everything that he purchased was going to be exactly in the stuff he gets. Well, he saw the black cabinet, and he just didn't really like it, and I didn't really like it either. It just didn't look good against the Moog, you know, the beautiful Moog cabinet here. And so he ended up buying a brand new 22 studio cabinet here from synthesize.com. And it's absolutely beautiful. It's a little darker, as you can tell on the camera, but it's absolutely beautiful. The wood looks great. This is the first time I've actually seen the synthesize.com Studio 22 cabinets. All I have is the portables. So seeing this beautiful wood cabinet's really nice, well made. And so he went with that. And as part of that, we used the modules that came in the original unit, and I put them in this cabinet here. So we got the slew limiter. Here's the pan fade now up here, which was right here. We got the instrument interface, and now this is kind of cool. We actually got some original vintage Moog panels here that were never filled. This is the sequential controller, the 960 and the 962, and we also have the 961 interface. So these are all really cool. We're just using them as blanks right now, but they may eventually become something if Andy ever wants to, or it gives him the idea that he can pull them out and he can put in other modules as he desires. So that's a really nice feature for him there. And these are just really cool vintage Moog panels. You don't see those very often. Something else I did for him. So Andy was telling me that he really used his Voyager quite a bit, and I kind of asked him, you know, before I told him I was going to do this with a cabinet, with his old black cabinet, I said, do you have a VX-351? He said, no, unfortunately, I'd love to have one. Well, I built him one. So now he has a VX-351 in a not Eurorack, in a 5U module format here. And I redesigned it as well. It's not to the actual Moog 351. I bought the cheapest 351 I could find, dissected it, looked at it, and I came up with better ideas of control. So I integrated those into this unit as well. And so we did that for him. So now he's actually got a VX351. And also I want to give a shout out to my neighboring company, Excel Graphics. They actually did the graphics on this for me pretty quick, actually. He just kind of surprised me with it. He said, yeah, I can make you graphics for that. He saw it, and so Johnny Edwards at Excel Graphics. So shout out to you, Johnny, and Sky as well, who actually put these on. So Sky, shout out to you as well. Really appreciate you guys at Excel Graphics. So he did that for me. Next to that, we got an amplifier. So we got an extra amplifier, which I put this in here originally for the idea that he can, patch into his buses and stuff like that, and use CV control to control the amounts and stuff, which I'll give you a demo of that later on here. And then we got the signal processor, which is a really handy module, the noise source that came in the original module, and then we got a vintage RE Moog incorporated blank. So that's making up the top cabinet. So not much in it, but there's a lot of stuff to do and a lot of stuff to work with that I think Andy's going to really enjoy. And once again, he's got the room to expand if he wants to add anything else. So really cool system, really nice system. But I'll give you a demo of this interface. Actually, this is a second video. I made a video before I labeled everything, so you guys can actually hear how this thing works. But anyways, I'll show you that real quick. So we'll show you real quick how this interface works that I built. So right now you can see we've got MIDI control. So we got MIDI control. We've got control from the Moog. So there's controlling the Moog. We can transpose using MIDI. So we'll transpose it to a fifth. You can hear. So that's how that works. We flip this switch and now we've got the Minimoog. So it is controlling the Minimoog. Now the oscillators in this Minimoog, I still need to service them because they're not perfect in tracking externally, but you can kind of hear them with all three oscillators. So it is with all three oscillators on, so you can hear the tracking between the Minimoog's oscillators, and that's not a problem with my module. That's actually this Minimoog. I hadn't finished servicing the oscillators, so that's the problem there. But once again, we got MIDI control. We're controlling the Minimoog. You can hear. So that works. That's only one oscillator, and the Dotcom will turn out the other two oscillators. So that thing sounds a little out of tune just because of the nature of it. Too low. So anyways, you can hear how the interface works. It's really handy. It's also really fun. You can do some fun stuff with it because we can do auto trigger. Shut that off. Get this set up here real quick. So there's that. Put the switch here on. We'll go over here. I'll show you this right quick. We got it sampling off the keyboard externally. Sampling off that. There's that. Turn the Minimoog on. Next we'll go and turn the other. So as you can hear, that interface works really great for some fun stuff here as well. But anyways, just want to give you a little demo of that real quick. I will show you the back of the modular right quick because I hadn't really showed that since I've done some of the cleanup and stuff. But anyways, you can see the new cabinet here, just how once again how pretty that wood looks. And of course the inside I beefed up the supply. We went from a 16 watt supply to a 75 watt supply. And I moved all the harness over from the original supply to this one. And just to show you an example, so here's our original 16 watt supply. And here's our nice new supply that's a lot larger. Actually, it's used. I bought this one used and just set it up for the plus negative 15 volts and got it running. But these are actually really nice supplies. They're industrial grade linear supplies. You'll find them in foundries. You'll find them in factories. You know, running equipment. So they're really they're pretty beefy supplies. And I just really want to put a 75 watt in there so it has plenty of power and plenty of current, plenty of overhead. So with this new expansion, that we don't have to worry about anything with current starvation. So now he's got plenty of wattage to work with, and no problems will be, you know, had in the future with this thing. But you can also see what I did here. So the VX-351 I built, I put all the connection back here for the Voyager, so you don't have a big old harness hanging over the front. So it plugs in back here. I didn't modify this cabinet. I tried to do this in a way that's very nice and neat. So we can actually take these out, and I just used the 2 holes for the 2 panels. So no extra holes drilled or anything like that. So this is completely reversible. If it wants to be pulled out, it can. Not a problem. So did that. But I'll show you the inside of this thing real quick and kind of see what the synthesized Dotcom modules look like from behind. So they're really nice. They're really clean designs. You know, really good. The only thing I will say about Dotcom is they use all the same color wiring, as you can see, on their harnesses. And that does make it a little bit tricky, especially when you're trying to troubleshoot or you know, you're trying to figure out where a wire goes. It makes it a little tricky, but they do have a good data sheet for their modules. So you can pull their data sheets and they have the pinouts and all that kind of stuff, which is really nice. But you can just kind of see how they look in there. Of course, you can see my custom module right there, my Moog Interface module. Looks very 1960s, so it looks like a Moog modular. But that's all hand built there. But like I said, that's the prototype of it, and just going to let Andy give it a good test and see if there's anything he don't like about it, and I can revise it and then get it more dialed in if it needs to be. But I've spent a lot of time with it, so I think it's going to be good. But yeah, anyways, that's a look at the inside here of the synthesized Dotcom cabinet in the vintage Moog cabinet. So pretty cool. Alright, I'm going to show you real quick the interfacing between the Voyager and the SPVX-351 I've built here. So as mentioned, it's kind of a modified version of the VX-351, which was this right here. But I've changed a lot of things up. I've put my own custom circuitry in there, and I've done things to really improve it. That this thing just really lacked, and so I've really made some good changes to it here that I think is going to be very enjoyable for Andy. And I may eventually build some of these. So if you guys are interested, I want to see how many of you will be interested in having one of these before I go out and make a whole bunch of them. Because I may actually start producing these things if it shows a lot of interest. But what I've got right now is just a very simple patch. We're just running strictly CV. So this is all strictly a CV setup with the Voyager. So we have no Midi. So no Midi's used on either this or the Dotcom. So we're running pitch output or CV output here, straight to the normalization panel of the Voyager. Of the Dotcom, and then we've got the gate coming out of the Voyager into the Dotcom. So that's our normalization panel as well. So that's what we've got. The big thing you're going to see different on this particular interface is that we've now have these 2 knobs, which you'd think would be the attenuators, but I've done away with the attenuators, which are nothing more than 10K pots. They're just passive. And I've installed my scaling keyboard circuit here to give you low and high range scale. So you can actually bring in the keyboard tracking correctly, and it's fully 100% calibratable on the spot. So that means that you can actually make everything work really well as far as tracking goes without having to open anything up or try to detune something to make it match on the low end or any of that kind of stuff. Right? We did away with all that. So this is really going to make it a lot more usable in that sense. But let me put the camera on the tripod and I'll walk you through the calibration steps and just show you how easy this thing is to set up. So first of all, before I do that, let me show you my setup real quick. So what you want to do to make this work is what I found the best way to do it is just turn oscillator 1 on only on your Voyager, open the filter up, set your footage to 16 for oscillator 1. So we're only hearing oscillator 1 set to 16. And then go to your slave synthesizer, whether it be a a Dotcom or Moog Modular or whatever you've got, and just turn up just oscillator 1 only. So we're using just this oscillator here, set to 16 footage, just like the Voyager. I've got it frequency centered on 0, and so that's what I've got going on there. Open the filter up, and so we're just going to hear just the oscillators, just the raw 2 oscillators, the one from the Voyager and one here. And what we're going to do is we're going to match, we're going to reference this oscillator to match the frequency of the Voyager, since it's the master. And I'll just kind of show you how this works. So let me put the camera on the tripod and I'll show you this. Alright, so anyways, we'll start first. I'll just kind of show you here how it sounds with these things zeroed out. So we got both the low and high zeroed out. You're going to hear that tracking's not correct. I just playing the Voyager there. So what we want to do is we want to hit low A and use the low knob here to actually pull that in for 0 beating in the correct octave. You hit your high A and then use the high knob here to pull that in without 0 beating, and then you'll just kind of go back and forth just like when you calibrate an analog synthesizer for you to have the low and highs correctly in. And so that's what the objective of this is. Now, if you're using this in combination with Midi from the Dotcom, you'll actually want to do a C note reference, and the reason is because that's a C note reference in Midi. So if you were to have the Midi combined, you need to hit the C note of your Midi controller, and then do this calibration to a C note reference on your Voyager. So that's how that would work in this application. Otherwise, when you do transpositions on your Midi controller, everything's going to be offset to a different frequency, so that you don't really want that. So anyways, we'll start here with the low A. Since we're just using just the Voyager, I'm going to just do low A and high A, since that's the typical Minimoog calibration. So we'll hit the low A, and I'm going to bring in this low. Like that right there. Now I'm going to hit the high A and adjust our high knob here. And there we are. And now you can hear how accurate that is in tuning there. So let me bring the camera back a little bit and I'll show you so you can kind of see both of these in the same shot here a little bit better. I just want to really show you that that knob position there. So I'll bring this back a little bit more here. There we go. Tilt my camera down just a hair there for you. Alright, so there we go. So now you can kind of see the Voyager in the shot as well. So I'm going to go down the scale of the keyboard to show you how accurate the scaling is now. And once again, we can change our footages. This doesn't affect footages. I still need to clean this pot here on this oscillator. That's what you heard there a little bit. So anyways, as you can hear there, that's our key tracking. And it's working great. We actually have full tracking over the keyboard, no detuning effects, any of that kind of stuff, except for what you heard there, the little wavering there. That was this actual switch of this Dotcom oscillator. I need to clean it a little bit. I did buy these modules used, and I did do a service, but I didn't really clean those switches, so I'm glad I caught that. But anyways, that's just a look at the direct CV reference. Now I'm going to do some patching. So what we'll do is I'll go here. I'm going to turn this to 0 here on this oscillator. We're going to take our aftertouch output here. And I'm going to patch into the oscillator 1 here. So now we're still only hearing just one oscillator per. So we got the oscillator 1 of the Voyager, this oscillator here. So now I'm going to show you the aftertouch. So if I bring up this aftertouch, so you can kind of hear there. So if we turn the oscillator here, you can hear it goes from 0 to 5. So it's combined with the Voyager. So there's your aftertouch. Something else that's really nice about it too is actually I'm going to go here and I'm going to patch our gates together here. So we'll go here and take our gate, we'll go to multiple, and we'll actually combine our keyboard gate here as well as our gate from our touchpad right here. So now we have both trigger from the touchpad here. We can touch it or the keyboard, as you can hear. So there's that. Now what I'm going to do is I'm going to take oscillator 2, we'll bring up oscillator 2, and I'm going to patch in from X, just kind of show you how all this works. So we'll go from X output of the keypad, or the touchpad, to oscillator 2. So now we should have control of oscillator 2. Like so. Then we'll take our Y-axis of our touchpad and go to the filter. So we'll go to filter input here, we'll close this filter up. So we got that right there. Bring up oscillator 3. So there's the Minimoog oscillators on. That's all 3 Minimoog oscillators and all the Dotcom oscillators on. So now what will happen is if I touch this pad, you're going to hear two things happen. You're going to hear the filter frequency change in the Y-axis, and then you'll hear the oscillator 2 frequency change in the X-axis. So we get something like this. And if I don't play the keyboard of this thing, you're hearing just the Dotcom being controlled by the touchpad. So you get something like that. So you can do a lot of really cool stuff with this. Plus we've still got other things such as the modulation bus, we got the wheels, we got a lot of things we can work in still with this module. The only thing I did not include in this version of the 351 is I didn't put the noise source output, I didn't put all the multiples. And of course the attenuators. We did away with attenuators because it's going into modular, so you've already got plenty of stuff. He's already got a noise source. You don't need another noise source. And so that's what I did to this one. But you can hear just how great this thing works. It works really good. And I also implemented the circuitry that you would have to come with the VX-351 that you have to plug in the Voyager to make all this work. I've added the resistors into this actual module. So you don't have to have a little module, little resistor block to plug into your Voyager to make all this work. I made it all self-contained. So it works really well here. Alright, I'm about to make you guys a sound demo of this thing, but just want to give you an idea of the setup real quick because it's hard to get all this on the camera once it's on the tripod. But I've gone strictly synthesizers.com with this setup for the demo. So we've taken down the Voyager. And so this is actually my personal 37-note synthesizers.com modular keyboard I'm going to be using. It's actually still MIDI based, but we have the modular capabilities of the pitch and mod section here, so we can patch them in and do stuff with them. Really fun little addition here to this keyboard. But anyways, I'm going to show you the patch here, real simple. You can also see just how few patch cables it takes now since I've done all the modifications I've talked about earlier. You can see that there's only just a few handful of cables used, and they're all audio based. So really all we have is we have the oscillator outputs for our waveforms into the mixer, from the mixer into the filter, and then from the filter into the VCA, and our audio coming out, of course. And then over here all we have is the pitch input for the normalization, and the gate output for the normalization from the Midi to CV converter. So pretty simple. So you can kind of see there just how clean it looks now with the modifications I've done. And like I said, I was trying to keep it really clean. So when this thing goes on the Moog Modular, which is already kind of pre-wired in some areas, this one is also pre-wired in some areas, still with the capabilities of plugging something in, breaking it, and still using it in a fully modular standpoint. But anyways, let me put the camera on a tripod here, and I'll start the demo. Alright, I'm just going to give you guys a good demo of what the synthesizers.com sounds like here, because I know I've talked a lot about the build here, but I hadn't really given you guys much of a good sound demo. So what I'm going to do, I'm going to just kind of show you like it would be a all-in-one synthesizer first. So we got the oscillators, the filter, the envelope generators. So it'll be very much like an all-in-one synth I demo. But just kind of give you a good idea of the sound of this thing. It sounds really good. They're great sounding instruments. And like I said, I've been around the Dotcom for quite a while, but I just realized I've never really shared a demo of really my instrument, of the one I have. I think I made a video like back in like 2013 where I was making like a cello sound or a violin sound. I think that was about as far as I got with demos. So this is a good time just to kind of really show you what the Dotcom sounds like here. And I'll start off saying that the oscillators in this thing is really nice. What I do like about them is they do naturally kind of drift a little bit, just like a Moog. So the oscillators aren't super tight, which is what you really don't want. You want them to be kind of naturally, drift and kind of naturally phase a little bit. That's part of the magic of really what makes a lot of the Moog synthesizers what they are, is they do have a slight drift. So it is pretty cool to hear that these oscillators have that. Now with that said, I have calibrated them and I have pulled them in pretty tight. And so you'll hear the footages work really well. That's the main critical thing about calibration, is getting your tracking in and getting your footages to work correct. If those are out, then you can have a lot of headache trying to keep something in tune. But I'll show you how this thing sounds. So here's all three oscillators on. We're using just sawtooth outputs right now. If I break it down, I'll show you each of the oscillators, independently. They're all identical, so they're all the same thing, but just kind of show you that they are working. And then I'll show you the transistor ladder filter, and then I'll show you the envelope generators and the amplifiers, etc. here. So we'll just kind of treat it like a normal synthesizer. So here it is, just a good sound out of this thing with all three oscillators on, filter opened up, kind of a raw sound on the sawtooth. you hear those oscillators, they sound really good. So now we'll just turn down and just focus on oscillator 1. Now something I did do after I made the Voyager demo of the SP VX-351, I did take this oscillator and clean the range footage switch. As you saw in that video, I was having some issues with it, so I've got that cleaned up as I'll demonstrate here. So here we go through the footages of oscillator 1. That's all we're going to listen to. And I'll go through the waveforms, etc. here. So here's the footage. As you can hear, it sounds great. I'm going to turn it up just a hair with this one oscillator. So there it is with the footage there. So there's our sawtooth. We'll start with the square wave or pulse wave. It's actually a variable pulse. We got ramp waves, which is reverse sawtooth. Sawtooth, which you've already heard. Triangular wave. And then we've got sine wave. So there's your waveforms there. So that's oscillator 1. Now we'll go to oscillator 2. You hear a good clean range footage switch there. We're on sawtooth as you heard. Now we'll go to pulse wave, same thing. So there's our square wave, our ramp wave, sawtooth, triangular, sine wave. I go up in frequency in triangular and sine wave because it may be easier to hear through some of your computer speakers. So there's oscillator 2, oscillator 3, pulse wave, ramp wave, sawtooth, triangular, sine wave, we'll go back to sawtooth, and there's the 3 oscillators. So as you hear, they sound great. That's the 3 oscillators. And so now we'll go to the filter. So I'll turn the oscillators off. I'm going to leave one oscillator on just to tune the filter up. So we'll go here. I'm going to unplug our envelope generator from the filter. So now we'll turn the oscillators down. And now here's just the filter tracking the keyboard. As you can see, now I did add the switch as mentioned, so I can flip that switch off, and now the filter is going to not track the keyboard. So you can see I can hit all these notes. It won't change the frequency. And there's our filter. So now I'm going to show you, just like I do in typical all-in-one synthesizer, I'll show you the envelope generator for the filter, the way I've got it set up here. So that's what I unplugged here. We plug this back in, and we have a range, so we can go negative or positive in polarity. So you can see I can go there. I'm going to turn it down in frequency just a hair. So we can go negative, positive. So that's our amount of envelope, or amount of contours it would be in Moogs. So there's that. So put a little bit of that on there. We'll close this envelope all the way up. It's just a click, as you can hear. The envelope's got a nice punch to it, just like a Moog envelope. So now we'll actually work with the attack. So we'll bring the attack up. Bring it down frequency just a hair. So there's our attack. It'll go a little bit longer than that. I'm not going to go all the way there. Then we got the decay. Which can get really punchy. So you can hear there's your decay. Set it back to 0, so it's going to be just a click again. Now we'll bring, I'm going to put up a little bit higher in frequency there. There we go. So here's your sustain. That's how low the decay will actually go. You can hear it doesn't go all the way to 0 in the decay. Put a little decay back on there with that combined. You can hear how that sounds. So there's our sustain level. Then we got the release. So as you can see, I'm going to put a little decay on it. Just going to follow up the decay. If I bring up the release, you can hear right now, if I let off a key, it's going to go straight to 0. As so. We'll put a little release on it. And it has that nice, like so. If I hold in the key, it's going to follow out the decay. If I let off the key early, it's going to follow the release. That's how that works. So there's that envelope generator. Now, once again, it's tied to this VCA here, so you can do a split. So you can actually use this as an audio VCA on a secondary channel and have the transistor ladder filter, the state variable filter going in separate channels to a mixer, pan them, and you've basically got two entities of an instrument. So it's actually kind of cool. So that you don't typically see a VCA in most all-in-one synthesizers. It's just a known thing that's inside. But since this is modular, you actually get to see a module that is the VCA. So it's kind of neat to see there. Because usually all you see is the envelope generator that controls the VCA. And maybe, you know, if you have an instrument with CV inputs for the VCA, that's really all you see. Because it's not something you really react with. But in a modular, you do kind of interact with it. So, because you can use it just for, you can use it for audio processing or for actual CV processing to make things have slow attacks and modulations and that kind of stuff in a voltage controlled format. So it's pretty cool. But there's your envelope generator for the filter and also for the amplifier 1, which it would be. Now I'll show you the loudness here that we're actually using. This is the VCA that we're using as the output, this envelope generator that's controlling it. So let me open this filter back up here. We'll turn our oscillators back on. Set everything to 0 in it. It's going to be just a click, as you can see. So I'll start with the attack. And there's our attack. Then we got the decay. Same thing here. So there's our decay. Then we got the sustain, which same thing, just like this. We can bring it up. It's going to say how low. A little decay on it. It doesn't go all the way to 0 like it does there with the sustain turned all the way to 0. So there's that. Then we got a release. So same thing here. If we set a little bit of release time, so I'll off a key, it's going to have a little bit of hold in the key, it's going to fall to decay. Let off the key, and we get that. So that's the basic principles of the synthesizer. I will go back and show you the state variable filter real quick. So we'll go here. We'll unpatch our transistor ladder filter. We'll put our audio into the state variable filter. We'll go here and run. The state variable filter gives us some options. So we have low pass, we have high pass, band pass, and notch as well. And so these are all voltage controlled high pass, voltage controlled band pass, voltage controlled notch filtering, and then voltage controlled low pass filter as well. So we'll start with the high pass. So we'll just kind of show you how this sounds. So we haven't moved our envelope generator over yet, so it's still in the transistor, but I'll show you just how this filter sounds real quick. And the same thing with this filter, I put a switch in here also for tracking. So right now it's off, so we'll put tracking on. So there's our high pass. I'll go and put our envelope generator on this as well. So we'll patch in this. So as you hear, we get a different flavor. So that's band pass. That's high pass. Here's band pass. Turn key tracking off. What I'm going to do is I'm going to set an oscillator over here to a different frequency. So anyways, you hear the band pass. Then we got notch filtering. Now notch filtering is kind of cool because it's almost like a phaser. Once again, we put a little bit of envelope generator on that. And so that's your notch filtering. We also have another low pass. Now this isn't quite Moog's low pass, like the transistor ladder filter. To me, this low pass has more of an ARP kind of sound to it, like when you think about ARP synthesizers. It's not a bad filter, and I want to explain that although I tell it's not a Moog filter, doesn't mean it's bad. It's got its own kind of character. So that's with resonance turned all the way up, and you can hear it doesn't quite have that self-oscillation like a Moog filter. We have volume control too, so you can kind of change your and then same thing here. We also have an inverted envelope input, so we have positive or we can go negative. What you can hear is it actually has a negative response. But yeah, that filter, it kind of reminds me like the ARP 4075 filter a little bit, just in the way that the resonance is and the frequency. But not a bad filter. You know, it's actually pretty handy, especially if you want something different, just a little bit different flavor than from the Moog filter. You got that option as well. So there's the two filters. I'll show you that the other voltage controlled amplifier works. Now for this, what will happen is actually we'll use this envelope generator here as our amplifier envelope. So we'll go here, we'll patch out of this, patch in that, sorry for the noise, and then we'll actually plug this in, and now we're going to be using this amplifier here. So I got to bring it up in volume. See, here we have a different effect of the envelope because we have it set different. So we'll go. See, you can see how that works. So it's just kind of a cool example of the other amplifier working. So what we can actually do, and I should have done this, I had it already hardwired, that's why you heard that hum like I had, is we can actually take this and patch into the other amplifier. Now we'll just leave that one alone, and then I'm actually going to take our audio of our mixer and put it into multiples, and we'll actually do a multiple patch here using one of these as the state variable filter, the other one as the Moog transistor ladder style filter. And we'll get something like this right here. So let me do this. So now we've got two channels. Let me unmute my channel over here at my mixer. Let's see, which one is it? It's going to be this one right here. So we should have, now I got some effects on it. Let me turn that effects off. I'm going to pan them so you can hear, what you'll hear is you'll hear the state variable on the left side, the transistor on the right. Let's go here and make sure I'm right here. See if I'm right. Oh, we haven't passed the audio back into the filter, that's why we're not hearing it. Here we go, we'll go here, pass this in, now we should have it. There we go. So there's our state variable filter again. We'll go to a high pass. So there's that one. Now I'm going to bring up the other VCA. Make it have a slow attack. Actually, we'll make it fast, make the state variable filter have a slow attack. as an example of two channels, they're sharing the same oscillators, but you could actually split up, you know, oscillators to different sections, etc. here and make something even more unique. In fact, we could do that like this right here. We'll put just one oscillator through the transistor ladder. Put a little glide on that. See here, that's just an example of having two separate channels, so to speak, kind of in a parallel situation on their amplifiers there. So that's a look at that. I'll actually go back here, and we're going to turn that one back down, and we're actually going to go straight back here real quick. So I'll plug this guy. I'll put him right back into our. Actually, want to go to the filter. So let me do this. This is what's fun about patch cables, is you have to keep up with which one's which, and I don't have too many colors to choose from, so that's why it's kind of confusing as well. Set this over here. So we want to actually go from there, unplug that guy, and we want to go from here to here. So now we're back into the transistor ladder filter. Should be here. There we go. So there we go. So now we're back into that, and this one here is no longer used. And so now we can actually patch our envelope back to our filter here. Just give me a second to get set back up like I was. We use this one right here. So there we go. Then we need one oscillator. We have one oscillator short here. We'll plug this one back in here. Actually, we got the cable right here. See, this is what's fun about modulars, keeping up with your cables. There we go, and I'm going to recenter that back to center position there on our mix. So there we go. We're set back up like a single all-in-one synthesizer. I'm going to show you some things that's kind of cool here. So I'm using actually my personal Synthesizer.com keyboard as mentioned. It has some CV stuff here. So I'm going to kind of show you a cool patch here, just how you can use a VCA also, not just as an audio path, but as a controller for modulation, etc. So we're going to go here out of my modulation wheel in this one, which is sending a CV voltage out. I'm going to go to a amplifier I have up here in this cabinet right here. We're going to go to control input 1. And then what I've got, just to save some space here, I've got my CP251 up here. We're going to use a triangular output of it, and that's going to be our control signal input, or our signal input. And then we'll use a output routed to one of the oscillators here. Do it like this right here. So we'll go positive output. You can also use the inverted output of the amplifier as well, because they have a positive and negative output. We're going to pass this into oscillator 3. So now what will happen is I'm going to bring this up where you can hear it. When I bring this up, we're actually controlling the VCA from this mod wheel, and it's actually got a modulation input. It's going to send the output the more I put on the wheel. As you can hear like this right here. As you can see, and we're using that VCA, the same kind of VCA you see here I'm using for audio. I'm using it to actually control a modulation amount. And you could do that with the envelope generator. You could patch envelope generator as your control source. For example, see if this cable here will reach, and we can just do that real quick. So actually we use this envelope right here that we're using for a filter. We'll unplug that, plug in this amplifier here. Delayed modulation. We can use our control 1 level here. As you can see, I can get a delayed modulation effect. Combine the other oscillators. Anyways, you kind of see how that works. So you can use the VCAs in several ways. That's just one example there of control modulation with a CV control. So that's kind of a cool example there. I'll just show you a few more patches here. We'll also go over some of the Midi stuff real quick. So I'm going to patch this right quick, kind of get cleaned up again. And I'll show you this real quick. So unplug, this is the VCA that we just patched into. I'm unplugging that so we don't have any modulation. Plug it from the CP251, which of course you can't see the CP251, but this is what it looks like. This is what we're using. That's the Moog CP251. So we're set back up here. We'll go to all square waves here. You get that really nice. Now I'm going to turn my attention more to the Midi section here, because you've heard glide. I have a glide right now. It's exponential. It sounds like the typical Moog modular, glide there. We also have a linear selection, so we can flip a toggle switch to linear, and now it's going to be a linear response like a Minimoog. Turn that down just a hair there. So you can see our glide response there. So there's that. Now we also have trigger options here. So I actually patched this back into this envelope generator here for our filter. Bring that up there. So we gotta go here. There we go. So right now you can see I'm in a single trigger over here. So this is all part of the Midi stuff. So right now I'm in single trigger. So if we hit a key, hit an upper key, it doesn't re-trigger. So we can go multiple trigger. As you can see. Or we can do trigger on release. So as I hit a key and release the key, it's going to re-trigger when I left the note. As you can hear. So it's really handy there for different types of playing. We also have note priority settings. Right now we're in low note, so it'll be just the low note only. As you can see, we can go last note, which it'll basically go either direction. And then we got high note priority. So if we hit this note here in the middle, lower note don't trigger, higher note will. Like that right there. So really nice feature there. So low note priority, that's your typical Moog setting there, where it's only going to trigger off the low note. Now as part of the Midi, we have some other things that's really cool in this Q174 Midi to CV converter. We also have a setting down here we can use pressure aftertouch, and since this keyboard actually is Midi based and has a pressure aftertouch keyboard in it, we can actually patch into that. I'm actually going to use a longer cable here. Let me get a longer cable over here off camera. So I'm actually going to patch from the pressure, which is aftertouch, and we're going to go just into another oscillator here. And if I hit a key harder, you're going to hear an oscillator frequency change. As you can hear. And of course, I like to use that more as a buffer, so I plug this into something like a amplifier once again, and then use another signal to control modulation. But it's just an example of how it works. So as you can hear it. So that's our aftertouch there, just kind of a cool feature there. Really nice to be able to use that. So that's our aftertouch control. We've got other things too, such as if you tie another keyboard into this thing, you can actually use another CV merge and have a secondary CV, a pitch CV reference, so you can do a euphonic kind of setup. You have quite a few options in this MIDI controller, which is pretty nice. We also have an arpeggiator in the Q175. So it has 2 octave, 1 octave. So that's it in 1 octave. And we also, it goes really quick too. You got a really fast rate. We'll actually set this thing up with a... So as you can hear, it goes really quick. We have an option of up only, down only, and then up and down. And so that's their arpeggiator it offers too, so that's kind of nice. And then you got, of course, the built-in portamento, which is either linear or exponential. But to be honest with you, I kind of like the slew limiter glide better, so I'll go to it, and we'll go here like this and patch in to this, and we can actually do a portamento that's actually analog, because that's a digital portamento. You hear a difference. You get a little bit more of that natural. this one in particular because it's directional, so we can make it go down. Let me turn that glide off, there we go. Here you can go down or you can go up. Or just natural. So as you can hear, it gets a lot better. You get a little bit more of that classic glide with it, where the one built into the Midi is a little bit more digital sounding as far as how it responds. Not bad, it's just something I find kind of useful in the slew limiter using it. Plus you get the directional control, which is kind of nice. You can do like those kind of Keith Emerson kind of stuff, like where you have a... as you can hear. So that's one reason I still kind of like the slew limiter a little bit better than I do the portamento here, but they're both really handy depending on what you're wanting to do. And both interface just fine with each other, as you see there. There is a few more things I want to show you real quick. One being the sample and hold module, the other one being the ring modulator. So I just want to show you how this works real quick. So first of all, like I said, I've modified the sample and hold with this toggle switch right here that allows us to do auto triggering, keyed auto triggering with the rate of the sample rate. So for example, right now we don't have anything connected, so I'm just going to show you how this works. So we got internal. If I hit a key, you'll hear that it's just a single note. I'll flip the switch. Versus that. And it's keyed, so when I off a key, it's not going to keep triggering. Now it comes really in handy what you're about to see. So what we're going to do, the sample and hold module, for those that don't know what it is, it's actually think of it like a keyboard circuit. So you have a sample LFO that's running, it's switching a gate on and off, and there's a sample memory capacitor in there that will actually hold the input CV at that given moment. And then whenever it's the LFO cycles back around, you'll turn it back on and it changes whatever the CV voltage is on the input. It's going to shift it to that, and it'll shut back off, hold that voltage. So basically it's just gonna it's a sampler. It's really what it is. It's a voltage sampler circuit. And what's cool about it though is that you can sample more than just noise, like what you get in your typical sample and hold, where you just get the sample and hold pattern off noise. You can sample waveforms. You can do all these kind of cool things. I'm going to show you how this works. So what we'll do first, we'll take a patch cable, clean up my patch cables here a little bit if I can. So we'll take this white patch cable here. We're going to go from input. We're actually going to sample, we'll sample the sawtooth of oscillator 1. Now we're going to keep this in an audio frequency range, which this is where it gets kind of cool. So it's still an audio frequency range. We're going to send that to the actual filter. So we'll go over here and plug out of that into the filter. Turn that knob down for level. And so there we go. So now we got a very simple patch there. So here it is going to be sampling the filter, or sampling the oscillator into the filter. And as I change the sample rate, you'll actually hear that sawtooth. Even though we're in audio frequency, you're going to hear it actually capture that sawtooth waveform in our pattern of our sample. So we'll go here. So that was sawtooth. Here's reverse sawtooth, or ramp. as you can hear. So you can hear that reverse sawtooth. We got triangular wave. And then we got sine wave. And then we can actually sample off the white noise or pink noise just like what you'd have in a normal sample and hold. It's going to be that random pattern. Like so. So as you can hear. So we'll go back to the sawtooth. And this is where it gets kind of cool. So we're going to take that. We'll do auto trigger. And because we're changing the frequency of that oscillator, you're going to hear the sample rate change because we're actually changing the frequency of that oscillator. So even though the sample and hold is setting at the same rate, we're changing the frequency of the oscillator, so it's going to sample at different points of that sawtooth. As you can see. So that's really cool. So that also, I want to bring this up first because now we're going to go to the ring modulator, and instead of patching this into the transistor ladder filter, we're going to pass this into oscillator 3, into our exponential frequency input with this level control here. Now if we just listen to the oscillator by itself, here's oscillator 3 just still as a oscillator to the channel here. We'll open that filter up. So I'm going to bring this up. And you can actually hear those waveforms even though we're still in the frequency range of oscillator 1 it's sampling off of. So that's it actually controlling frequency. Now I bring that up because now we're going to go to the ring modulator. So what we'll do is we'll actually unpatch, let me actually go here. We're going to leave that into sawtooth. We'll unpatch this. Sorry about the train going by here. So we'll patch that to output, so now only channel 1 is going to be there. We'll patch oscillator oscillator 2 into the X channel, and then we'll put oscillator 3 into the Y channel. So X for oscillator 2, Y for oscillator 3. So now we're going to change the waveforms to sine waves. And so it's not going to sound very unique until I start changing frequencies and getting the oscillators more separated from each other. Here's what it sounds like through the ring modulator just like it sets here. If we change the waveform, we'll go to sawtooth so you can hear it a little bit better. So there it is there. So now we'll go here. I'm going So if we go to a square wave, it's really noticeable here. But as you can see, we're matched kind of in frequency right now. We got a little offset in the beating, but we can adjust that out real easy like this. So as you see, it's not real impressive until you start separating these oscillators out. We'll go here to sine wave. So anyways, you can hear all those different results you can get from that ring modulator. Or you can just turn that down and just have a... Anyways, that's the ring modulator, so I just want to show you that real quick and just kind of give you an idea of what that is. The other modules we have, of course, we have noise source, which you've kind of, you know, it's what it is. It's just white noise, pink noise, or low frequency. We got a signal processor, which allows you to offset gains and offset of inverted or non-inverted signals, which is a really handy module. We got the amplifier, which I've already kind of demoed with the modulation kind of stuff. We got an instrument interface as well. Now what this does, it allows you to plug in instruments like microphones, guitars, and then trigger your envelopes and that kind of stuff, and have interaction between the instrument and another type of instrument just based off the audio input. So that's really nice. We got a pan fade module, which allows you to actually hook this up to LFO, for example, or just use a manual control to pan a signal and fade. Which is kind of nice. Slew limiter, which you've already heard. And then we got these extra areas here for future ideas or, you know, other modules that Andy may want to put in this thing. But just want to give you a quick demo of that real quick. Alright, I've now got this thing complete with the Moog 1C below it. As you can see, it's a monster of an instrument. Now we actually got a 3C. It's pretty wild here. But I want to introduce you to the owner of this instrument, Andy Welchel. Is it Welch or Welchel?
Welchel.
Andrew
Welchel. Electroclassic Orchestra.
There you go. Check him out on YouTube, guys. He's
Bach Rewired.
Yeah, he's a really good artist.
Spotify.
He's got some great music out there. He's a really great player, and he's using vintage instruments. He's using polymoogs and this thing right here, and he'll soon be using a synthesized Dotcom mixed with this thing. So
let's hear it, Jared.
Pretty cool. Let's hear it.
Let's hear it.
So what we're using, I'll show you real quick the controller. We're just using the once again, a synthesized Dotcom keyboard, because the 950 he didn't bring it with him, but that's okay. And so we're going to be using that as the keyboard, and we'll make you a demo here. Alright, so I'm just going to give you guys a quick little sound demo of these combined here. So right now I've got the synthesized Dotcom muted here, so we're just going to hear just the Moog, and then I'll bring in the synthesized Dotcom by unplugging this dummy cable here that's going to my VCA, so you can hear this thing as a combined unit. So here's the Moog. there's the Moog. Now I've turned the Moog off here. I'm going to unplug my dummy cable. So now this is just a synthesizer Dotcom. Then I'll combine them by flipping this toggle switch on my module. And then here they are together. So anyways, you can hear the power of this thing. It's just fantastic, and they actually match pretty well against each other. They're both pretty powerful instruments here. But anyways, this is the follow-up to this final part of this video. Appreciate you guys watching, and a special shout out to you, Andy, for giving me the opportunity to work on this thing for you and get this thing built up. And there'll be more here to come here very soon. Take care.